Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 game development live stream. Today we're going to be diving back into the weeds of video modes and VRAM management. I'm honing in on what's going wrong. We took a little break, I got a haircut. Let's see if we can actually solve some of the problems from last time. I've had a lot of time to stew on them, I've had a lot of time to think. Let's pull up the game and just have a quick look. Okay, so we've got a little box person. There should be some tiles drawing here, and they're not. Also, we look like we're a little bit more rectangular than we should be. I'm not sure that the aspect ratio is correct, but that is yet another problem we're going to have to tackle at some point. So that's our video mode problem. Then we also have this weird thing where there's this like screen corruption when we try and load a tile set into memory, but that kind of goes away when we move away from the part of the scene that loads that tile set. It's a bit tough, it's a bit iffy. So I noticed something cool. I noticed something really cool that makes this look a little better, which is that if I don't load the other level, like if I only load the first chunk of the level, it doesn't do the corruption. So that's good. Now I'm just going to double check. Because I think actually maybe I might have changed the state of this a bit. Entry. Oh yeah, I changed this so it's only uploading once. Let's double check. I think if I only load this one level, it's okay. Yeah. Kind of. So if we only load one chunk of our level, then the tile set works. If we try and load more things, it's a problem. Awesome. Pure C or C++? Hold on, I don't want to drag this whole window. What am I doing? I've forgotten how to stream. Let me get chat out of here. Okay. Pure C or C++? This is pure C. There's no C++. I don't like C++. The Lua stuff, I've actually decoupled this from Lua. So this little chunk of the project is just C. The Lua stuff is still there, but it's decoupled from the main engine. So if you don't like Lua, you don't have to use it. It's an important architectural change. OpenGL, no, I wrote my own graphics driver for the PlayStation 2. If I want to draw a rectangle, I have to put those bits into a buffer to make it happen, which is fun, which is really, really good. Cool way of working. Yeah, Lua is good for prototyping some things and for messing around and doing simple stuff. The performance was a problem, and some of the benefits of the dynamic language weren't coming through because the Lua exception handler uses set jump and long jump, or the kind of, you know, the what do you call it? Error handler, p-call, protected call, whatever. It uses set jump and long jump, and there's something about the implementation that sometimes causes a null pointer exception, which if you're running in PCSX2 just hard crashes the emulator. So the debugging experience freaking sucks. It's really, really bad. And it's really easy to make errors in Lua that cause that kind of p-call error bubble up. Cricket looking fresh, thank you. I'm feeling fresh, okay? It was time. I was getting too fucking bald to have long hair, so we're short now. We're back, we're stylish again. It's good. I got a new jacket as well. I'm feeling good. I went out wearing a cap the other day. I don't know who I am, you know. It's a changed world. So, load one level, tile set's there. If we load a second level, we're suddenly very unhappy. Okay, well, the tile set doesn't disappear, which is weird, because usually it was disappearing. But we still do this, like, weird corruption thing. But that only happens when we load this second chunk of the level. So let me try loading this a different way as well. What if I just get rid of this, but I still do this swap? Because we have two level buffers. We can load one chunk of a level and then, you know, kind of preload another chunk. Okay, so if we swap the buffers, we get the weird screen bug. And if we don't swap the buffers, we get no screen bug. So the problem is with the second buffer, or the first buffer, I guess, depending on how you want to think about it. What is rewards enabled on channel? Get out of here. I don't want to see this. Good application. Lua can be useful as add-ons. Yeah, exactly. Yeah, my idea is that, you know, I can do all the nerdy PlayStation 2 stuff and you can write a bit of Lua to make stuff happen. And I always want to keep Lua as a kind of scripting thing. It's cool that I have Lua wrappers into a lot of PlayStation 2 hardware. That makes exploration kind of fun. Yeah, I'm definitely keeping it around. TZ1N, welcome, by the way. You're a first-time chatter, I think. So, you know, welcome to the weird PlayStation 2 dev streams. Exploiting? We don't need it since we're on C. We have all the power in our hands. Yeah, but doing some stuff in C sucks. C can be hard. C is not very expressive, and that's something we're bumping into right now. Okay, so when we swap this buffer, things break. Now, we actually have this cool thing that we can do. So if I go into my temp directory, and I think it's called GSD. I don't think the directory exists. I think I have to make the directory for it to appear. So if I run this, it's going to dump, I think, my first 100 draws into this folder. Let's get rid of my home directory. No one needs to see that. So this is everything that PCSX2 has just done. C doesn't suck. You're working on C. No, C sucks for certain things, especially like gamey things where you have like, I don't know. Some stuff is easier to do in a scripting language, and some stuff's better suited to a scripting language. When it comes to like the bit manipulation stuff, C's perfect. So my goal with integrating with Lua was to use the right tool for the right job. But C is cool, and I think you can do a lot with C. You know, Quake 3, it's just C. The whole engine is just C code. It's a beautiful, beautiful code base to look at. But I do think that a lot of gamey stuff is better suited to a kind of more dynamic language, especially when you're just experimenting. So we can pull up, we can have a look at the images that this pipes out. So like the first one is black, but then it's like, hey, okay, here's in a more squashed aspect ratio, the first frame that we draw. This is the alpha for that frame. It's just gray. And then we have another one, and if we pull up add bar, we can see the draws that these correspond to. So we can pull up the whole context of the PCSX2 emulator when this thing gets drawn. This is the most powerful debugging tool we have. And you'll see that, you know, we can kind of see gravity applying slowly. Our box is going to move down. Annoyingly, we still have these alphas rendered, even though my alpha is uniform because I'm doing 2D rendering. I have no alpha test. And we're back to the start. Okay, so we don't really get a lot of meaningful stuff here, but that's good. That's good. Now, does this one have the bug? No. So that's good. So that's what we expect to see. And I don't think there's actually a lot of value in looking at it with no bug. We want to see it with bug. We want to do a dump with bug. So I'm going to remove everything here. I'm pretty sure everything gets overridden anyway, but just to be safe, I'm gonna remove everything every time I do it because I don't really understand how this works. GDB for inline and runtime debugging. Okay, so I'm writing code for a PlayStation 2. Where's GDB gonna run? Right? Am I running GDB on the PlayStation 2 and then running my binary inside it? Because the PlayStation 2 doesn't have an operating system. The PlayStation 2 doesn't have an operating system. I could run GDB. I can run PCSX2 in GDB, but that's a whole other kettle of fish. Yeah. So there is some work for debugging, but and again, one of the benefits of doing things this way, not this way, not this code. This code's all C, but with having the Lua to begin with, is that you can hot reload Lua really easily. So my goal was that I could run a game over the network, and then rather than having to recompile and reload an entire ELF binary, I could just reload a script, and that's better for iteration. Yeah. Right tool for the right job, right? But definitely, I think people sleep on GDB and how powerful GDB can be. Okay, so we've just dumped all of our draws again. And let's look at them this time, right? Because we're going to see, we can kind of see maybe the bug here. Yeah, it's cutting off some of these tiles. And it might start cutting off this one by the time we finish. Probably not. Okay, so we're seeing some of these tiles are cut off. The reason for this, the reason that this is going to happen, okay, the reason that some of this is cut off is we're uploading a tile set into VRAM and it's overriding, or we're uploading some garbage into VRAM and it's overriding part of the tile set. Or we're trying to read the wrong section of VRAM for the tile set. No, hold on. The screen doesn't move. We're drawing... We're overriding part of the frame buffer with something, right? We're overriding part of the frame buffer. We have this section of the screen that never moves, and it probably is related to one of the tile sets being uploaded. So, I suspect I'm going to fix this. Actually, I'm going to try and do something to fix this. Now, if I only draw one of these levels, I think this is the wrong one. I think we're going to see nothing here. And I mean, drawing nothing, that's a valid strategy, right? If we don't draw anything, we don't have any bugs. So that's good. So what if we just skip drawing the second one? Do we still have a bug? Yes. So this is good. That's the most progress towards honing in on what's going on here I've made so far. So Let's have a look. Let's pull up this again. Okay, so interestingly, we have a frame of nothing. Let me, if I get rid of this swap, I don't think I had a frame of nothing. But maybe this is just non-determinism. Well, if I do this, I have every frame as nothing. It might just be non-determinism. I don't know exactly what triggers these draws and this logging of stuff. Anyway. This is interesting. I don't know why I get a frame of nothing. Let's investigate this. Let's investigate this. So this is draw 5 and this is draw 8. So let's look at 00005, the context here. We can see what the frame buffer is. We're double buffered, so we have a frame buffer at 0 and we have a frame buffer at 8CO, whatever this is, multiplied by 32 and then multiplied by 32 and then also multiplied by 64 and then also multiplied by 4 to get the actual byte VRAM address. Or I guess left shifted by, what's that, 8 plus 5, left shifted by 13, is that right? Feels like too many left shifts. Anyway, feels like too many zeros. Bobby is too welcome. Welcome back. Welcome back. I'm back. You didn't go anywhere. I did. I'm looking different. I'm feeling different. It's a bold new frontier of my live streams. So this is interesting because we can see that the background is just like garbage, or like we're not actually drawing a tile set. And the tile set we're trying to draw here, it says it's at VRAM address 0, but VRAM address 0 is a frame buffer, and it's probably an empty frame buffer, so it kind of makes sense that we're not going to draw any tiles. So that's good. That kind of makes sense. Kind of makes sense. 0000. The next draw was 0008. This was the other thing we saw. Now when we look at this, we could see tiles, and that's because the tile set has been set correctly in the register. So there seems to just be like a one frame of lag with this, which is weird. Makes me kind of nervous. Makes me feel like maybe that has something to do with what's going on here. At some point, we're overriding a section of VRAM with the clear color. That's the other weird thing. We're not like zeroing it out. We're overriding it with the clear color. So it feels like maybe we're copying one section of the frame buffer into another, and a section that always ends up as the clear color. Maybe. But we're doing that after. We're doing that after we've drawn other stuff because it appears on top, right? So after we've drawn everything. So what's the actual order of our draws here? I know that's very small, by the way, but it's very hard for me to read if I make it this size, so it's going to unfortunately just have to be small. Bobius, what's been going on this week? What have you been up to? What have you been building in the last like week and a half, 2 weeks? So when we draw, I guess the other thing we do is draw entities. What if I just skip drawing entities? Let's just, I'm trying to work out exactly which line of code causes this problem. And it's not drawing entities. It doesn't really make sense that it would be, right? Because it only happens when we've loaded this texture into a certain slot in VRAM, a certain place. So what if I do something crazy? What if I do something really, really crazy? What if instead of doing this, all this VRAM stuff, what if I say VRAM head? What if I just say these are all at, what if I just say VRAM start, VRAM head, VRAM head? What if I do this? What if I move these things to overlap each other? We still get the issue. See, that's weird because these should now start at different places. Well, I guess it isn't weird. Still messing around in D, exploring the language. Nice. Keen to see what you discover. I should do a D stream. D has always fascinated me from a very young age. It's so maximalist in its design, right? Tonight you say Galvec on your hardcore Iron Man requires single tasking. Good luck. Thoughts and press. I'm sorry to hear you're playing so much RuneScape. My condolences. But thank you for stopping by. Thanks for the compliments on the haircut. You know, I've already got a pretty big ego because all my friends are telling me it looks really good, but I'll always take more compliments. Cricket, are you going to play the CPMA comp? The 2v2? Is that next Sunday? This coming Sunday? Have I committed myself to sitting inside for like 2 hours and talking at a screen? I'm going out that night. I may not cover the whole comp, but I am commentating some of it. I promised Profanum, and that's my excuse for not playing as well. Haven't booted up the game in a while. Not since we played, actually. So anyway, I'm getting really off track. Actually, no, I played after that. I played someone, Birdo. I think I played Birdo on CPM 15, and it was fun. Game's good. 0 to lose both maps and go 0 to 120. Yeah, CPMA 2v2 is brutal. It's really brutal. You gotta have good fight skills. Anyway, good luck with your hardcore Iron Man. I hope you find a teammate. There are some people floating around, so I'm sure you'll find someone on the day. Okay. So. I think I'm cracking the code. The VRAM head here is 2742144. Okay. The VRAM head here, if I do the swap first, is 129. So the lower VRAM address is causing issues. The lower one, which doesn't really make sense. That makes no sense to me at all. So here's what we're gonna do. When we do this, we're gonna say VRAM head. Actually, we should do that before we call context init. We should do this in main. Before we call context init, we're gonna say VRAM head plus equals. Did I add? I guess we could just alloc VRAM pad. Let's go VRAM pad. VRAM pad. VRAM. Let's pad it out by just like a kilobyte. 1 whole kilobyte of our precious 4 megabytes. If I run this now, do we get the same behavior? Does it move it? It maybe moves it a little. Why? I need to know why. So I think I worked out, right? It was something like, 8024 isn't a power of 2, but that's okay. We need to be a little bit careful. But this moves this box. So why is this box here? And this is probably the most obnoxious place I've been able to put it. So let's have a look. Let's have a look at our drawers. Okay. So here we have just the entity for 1 frame. Here we have just the tiles for 1 frame. And here we have the tiles and the entity. Except it's not really a frame, it's like a drawer, right? So this is all in frame 45, I guess, maybe. Something like that. I don't really know what these numbers mean. I'm just kind of guessing. Well, this is different. I don't know why he's on his own sometimes. I don't know. Okay, that's weird. It's very unusual. Very strange behavior. So this little void here, and it's the color of it's the color of the background. That's the weird thing. Like if I move this around, so this is the VRAM address. This is where the tile set lives in memory. Where it lives in VRAM memory. Why does that? Because we're uploading a tile set, right? But it's kind of maddening, okay? Because the tile set we're uploading isn't the clear color, right? We're uploading a tile set that has these weird, gross-looking numbered tiles on it, and somehow when we upload that, it puts the clear color over a chunk of VRAM. I'm a bit lost. About how this is even possible. I really am. Let's look at some of these drawers. 28. 00028 context. Okay, so what is... So our frame buffer's at 0 here, our Z buffer lives down here, that's fine. We don't really... Z-test. Z-test's enabled. Can we Would it be possible to fill the VRAM outside of what I'm actually using with some kind of bit pattern? Possibly. Writing arbitrary data to VRAM, surprisingly not easy. I'd have to set up transfers in blocks of something. It would be non-trivial. Is what I'm getting at. Also, for the bit pattern to be regular, I don't know. I guess the TRX texture transfers from CPU to VRAM are non-trivial. I have APIs to do it. So maybe I just upload a bunch of textures. But I could make a texture, right? I could make a texture that's just like some alternating pattern. That's like 64 by 6. That's 100. Does it go 256 by 256? I don't care about that crash. T. Hello. There we go. Let's go 256 by 256. How big is this? 256 by 256 by 4 bytes per pixel. Oops. Wrong operator. This is... I should be able to do this in my head, actually, because... Okay, hold on. So this is 2 to the 16. This is 2 to the 16. And the 4 factors out because it's 4 megabytes. 2 to the 16. That feels too big. So basically this is less than 2, right? Because this is the number of bytes that the VRAM we have. This is the size of this texture in 32 bits a pixel. Yeah, that's not good. 4 bytes. Megabytes. Okay, so maybe that texture's too big. If we just go to 64 by 64 textures... Oh, hold on, I did that upside down. That makes more sense, doesn't it? That number didn't really make sense. It didn't make sense that we wouldn't be able to fit one in memory by that much. But it's still less than... Oh no, 16. Okay, so 16 of these textures exactly... Oh yeah, 2, 4... I don't know. I think I was counting in... I think I was counting in a powers of 2 way, not in an integer way. Anyway, we just need a regular pattern. So let's go grid. We're gonna make a disgusting garish color on a 16. Let's go 8 by 8 grid. And we're just gonna upload a couple of copies of this texture. I think that's a good idea. And let's make it really horrifically ugly. So B, is there an option to stop at, maybe not, settings, no, maybe not, maybe that's Asprite, maybe I should have done this in Asprite, but if you read my blog post today, you'd know I uninstalled Asprite. Let's do green, let's do purple and green, those two colors famously go really well together. We just need a few of these and then we're going to copy paste. I'm sure there's a better way to do this. One option would have been to do it downscaled, I guess, and then just like upscale it. Cool. But so the goal is to have really hideous colors so that it's very obvious where this is and where this isn't. So this is actually a very good idea. It's a very, very good idea. This is about half, so then we do this. Cool. Then we do this. Riveting stuff, I know. Someone tell me a cool programming fact in chat while I while I work this out, while I make a pattern. Excellent. So this is a proper like clown vomit. Oh, it looks like a sphere. It's like an optical illusion. Okay. Workspace. Workspace. I have a lot of files in my home directory. Workspace. PlayStation 2. Side scroller test. Source. Yeah, source. We'll call this test fill.tga. Has to be a target. Has to be not run length encoded. Origin in the top. Actually, origin top left or bottom right doesn't really matter here, funnily enough, but we're going to put it there anyway because that's where everything should live. And now, two things I want to do. One is I'm not going to clear context. Do I automatically clear the frame in my frame start code? That would be kind of silly. PlayStation 2. Clear buffer. No, I don't. I manually clear the frame. Where am I clearing the frame? Where am I clearing the frame? What does that look like? Frame start. Oh no, it is in frame start. I always clear the frame. Okay, I don't have an option to not clear the frame. That's okay. That's okay. We can deal with that. This still works. This still works. So what I'm going to do is I'm gonna put this locally inside this level, because on this level's heap I'm going to load a second texture. And I'm literally just going to put this everywhere in VRAM. I'm gonna put 16 copies of it in VRAM. I'm gonna do it. I think that's the right way to go. So we're gonna have a texture called filler. We're gonna say int. We're gonna say rc equals tga from file. What'd I call it? Testfill.tga. And we're going to use our levels allocator because it's all going to go in this levels heap. Okay, beautiful. Then we're going to do this, but we're going to put it... And this has to be in VRAM. So what we're going to do, we're going to do something very cheeky. We're not going to give it a real VRAM address. So this is going to TGA fill pixels, TGA fill pixels size. Cool. And we're going to say that the VRAM address is 0. This is very silly. This is very silly. Now, the first time we draw this thing, so if it's the first time, so only the first time. We do this once. This is a once block. Refraction PCSX2. Did I solve my problem? Not really. I'm making progress. I've worked out that it's my code doing the VRAM stuff, doing something weird with VRAM. I've had a suggestion to fill VRAM with some junk and see if that gives more of an indication, like a pattern that I can see. So I'm going to do something strange. I'm going to try and draw this texture to all of VRAM. Copy it to all of VRAM. And we'll see if that works. And that should hopefully give us more information at least. So if it's the first time we're doing this, so what I'm going to do is, okay, I'm going to grab, I'm going to do a for loop. I guess I'll say I equals 0, I less than 16. Cool. So we're going to tell it that the VRAM fill, I need to change the name of this. Yeah, filler. So this, instead of tiles, should be filler, because this is what we're just going to fill VRAM with. Oops. Filler. Cool. So this is kind of like a fake texture, right? Normally a texture we allocate somewhere into VRAM as part of our like level, but this we're going to start at 0. Okay, we're going to say the VRAM address, we're going to do this 16 times. Every time we're going to advance the VRAM address by a 16th of total VRAM. So we're going to say it's I times 4 times 1024 times 1024. Which isn't exactly... and then we have to divide this by 4. So actually, it's a word address, so we'll just do this. We'll just do this. There's 1 megawords of VRAM. Cool. And then we just upload it into VRAM. Add all those different addresses. This is a great hack. This is a great hack, and this is going to work. This is going to work perfectly. There's going to be no compiler error apart from that one. Nothing can go wrong. Nothing can go wrong with this. Apart from that. Bad dimensions. Oh, yeah, I forgot about this. This is in Draw 2D for some reason. Bad dimensions. EE VRAM size. Width times height times 4. If it's bigger than texture size. Shouldn't it be I times 256 times 2 times 256? No, because the 4 only... 256. No, so the VRAM address... Oh yeah, you're right, hold on. I meant to do this divided by I. No, yeah? I meant to do this... What am I doing? I times 1 over this, right? No, hold on. What am I doing? What am I saying? Is that what I want? I want like... You're right. I'll just do it this way. It's smarter. Well, it's dumber, but it's smarter. But we still have this thing where it's like bad dimensions, texture size. The texture doesn't fit in its dimensions, and that might be because... Oh, hold on. I think I need to add an alpha channel. I think I only support... I don't properly support 24 bits per pixel, so it gets a bit confused. Let's try again. Yeah, I guess that makes more sense. Okay. So we saw it for a second. And that's kind of good. It means the frame buffers are completely overriding everything, maybe. So let's have a look at what happened. Let's have a look at what happened. Oh yeah, I am. Hold on. Wait. I missed I. I missed I. I saw it for a second. I saw it flash. This definitely draws a lot more like black. And I'm guessing that's because it does something about the... Oh, there's one. There it is. So there's our filled frame buffer. And that does... Then there's just black. And then it goes back to... I don't know why there's black frames in here. It does this. Okay, that's very concerning. Oh no, I guess it isn't, because we see it once for each frame buffer. So that's good. So what if the black is just the alpha? No, some of those aren't just the alpha, right? So you can see in my magic bar here, right? So this is the color, this is the alpha. And these are just like, I guess it's triggering more of these because I'm doing all of the stuff, but some of these, like, so we draw something and then this is the alpha. And then there's a black draw, and then this is the alpha. But this is still in draw, I don't know why I'm pointing screen. This is still in 5. So I'm not really sure what's going on there. And then the first time we draw the second frame buffer, we get a thing. Was that the first time we'd seen that? No, that's the... Yeah, so the first time we see each frame buffer, we see that. And then we get all this stuff. Not drawing to... It'll be blank. Yeah, exactly. So that makes sense. That makes sense. We want to see it twice. Yeah, all good. All good. Thank you, refraction. This doesn't add up to enough powers of 2 though, right? So 2 to the 8, 2 to the 8, 2 to the 6. So 2 to the 20 is the magic number, right? And 2 to the 8 times 2 to the 8 is 2 to the 16, and 16 is 2 to the 4. So that does add up to 2 to the 20. So we should, that should be filling all of VRAM. That should be filling all of VRAM. That should be okay. So this is behaving like we'd expect it to, which is good. What if I upload the texture first? That doesn't make sense. Now, then the texture is just going to be the clown vomit tiles, which works as well. Or just nothing? Huh. Unexpected third option? None of the above. Where'd our tile set go? Unexpected third option. It's also like, what if we just don't upload a tile set, right? Then do we get... Okay. I'm more confused now than I was before. So, if we do this before we draw a bunch of tiles, we get, like, it just flickers and it's gone, and that's good news. But we get this box that stays over everything. I guess my question is, if I do this the other way around and I try and upload the texture first, and then somehow that makes the tile set disappear, do I still get a box once I leave this area? No? What the fuck? Actually, how does that work? What? We get it over here because now the tile set's loaded again, just in a different level buffer. But once we come back over this line, it's like, nah. It's gone. Okay. Okay. I can deal with that. So, the other thing is, right? Hold on. If I leave this inside the block, then we don't get the corruption. If we don't upload the texture every frame, we don't get corruption. But we still don't get a texture. Where did the texture go? So, this is kind of cursed. Refraction, welcome back. I don't know what's going on. So my idea is that I want to be able to have 2 levels that both use the same region of VRAM, right? And I want them to be able to upload and then draw every frame. Now maybe, but it shouldn't matter. It shouldn't matter. The timing issue shouldn't matter, right? The fact that I'm uploading a texture and then issuing a draw, at worst, as long as our VRAM is well behaved, we're going to get some corruption, some level of drawing from the wrong wrong data in VRAM, which will be like the previous level chunks tile set. GS is very linear in drawing, yeah. And from my understanding, if we issue that upload first, it's probably gonna finish. Yeah, we have never bothered with any timing stuff. That's good to know. I'm not thinking about timing. But so what was interesting is, so this is my upload texture to VRAM function. And I call it every frame. And when I call it every frame, that's when this corruption happens. Right? That's when this box comes out to play and does nasty stuff that we don't like. So what's interesting is, once I stop doing that every frame, the box goes away, but so does the entire tile set. And I just don't know where it goes. You could see flashing pixels in the box. Was that just, you sure it wasn't my mouse? I can't see anything inside the box. It could be some like weird stream artifact. My aspect ratio is still not right as well. Like I don't want to forget that. I'm pretty sure it's too skinny. Am I using that Oya VRAM for something else? No. Currently no. Or am I doing a clear? I'm potentially overzealous in my clear. Oh, the same color. Yeah, it flashed. Yeah, it definitely flashed. At the start of every startup, it flashes. I can see it. You maybe can't see it quite as clearly. But it definitely, like, the whole screen flashes that color. It's just weird that the whole tile set is gone, right? But I guess it makes sense. It makes sense. Because we think the tile set is here, right? Literally like where my mouse cursor is. So that does make sense. We're reading a tile set as if it's here. It's just... No, and we're not uploading again. Yeah, okay. So we're reading the tile set as if it's here. And because we're clearing the screen, we just read nothing. Oh, pinkish color, original numbered tile set image. Okay, I haven't seen that. I haven't seen that. But it's not possible. It's not impossible, because what we basically have is a timing issue, right? The reason we can see the tile set but see the box is that when we upload, like, we're obviously uploading the tile set somewhere that's valid, and we're somehow issuing a draw against it. We're just also somehow drawing, like, we're also just somehow uploading garbage into the frame buffer as part of that process. So let's interrogate our screen clear function, because it does a lot of stuff. It does quite a lot of stuff. Well, we're just calling screen clear, right? Width, height, and we've got our clear color. Just seems pretty good. We tell Z to always pass. We remember our depth tests. Maybe I should check my trace logs. Maybe I should just see what resolution I think I'm clearing, but I know that's pretty right. Oh, that clear's going to clear all memory. I'm going on 2048. Either way, that should be the thing happening first. I would have thought draw clear. Because I thought that was my, like, frame. Huh. I'm not exactly giving this an address, am I? Is that the problem? What does draw clear do? Hold on. I need another editor. PS2 SDK. What does draw clear do? Going from 0. But this draws against the frame buffer, right? If I'm going from 0. I thought my frame buffer was centered at 2048, 2048. I thought that was how the coordinates I'd set up worked, because when I draw, like, anything, I add an offset of hex 8000 to it, which is like hex 800, because like I'm adding an offset of 2048 to everything I draw to get it in the middle of the screen at 0, 0. XY offset, yeah, so XY offset is 2048, and this, or like, no, not 2048, it's 2048 plus half width, so 0 should be in the middle of the wait, is that wrong? Is that backwards? Subtracted. Hold on, I can just look. Why am I trying to make it up? Let's look at vsync. Let's look at a healthy amount of the way in. Let's look at this. This isn't in here, is it? XY, this is in, let's look at 00010 context, and XY offset. Okay, so these are numbers, 27648. Should be adding it on if there's an XY offset. So subtracted. I should be adding it on. So how does this work? Hold on. How am I drawing anything? Everything is being called into question. So this value here, right? This is in GS coordinates. Yeah, this is in like fixed point, floating point. Not that it matters. Not that it matters. Yeah, it should be 204.8 plus X. So then how does this work? What have I done? I wrote this code so long ago. This is my code. This is PCSX2 code. So 204.8 plus X. Yeah. So, which is what I'm doing. So this should be plus, and this should be plus. X, Y, width, height. Yeah, oh, okay. Let's try this. Let's try this. Error? Common.o error. Where's my error? Oh, hold on. I've got to export platform equals. I should make this the default. There we go. Is my function multiplying those values by 16? So I'm just calling the PCSX, the PS2 SDK function, which should be doing it. I think this does conversion properly to make him. I assume so. We'll find out in a second. We'll find out in a second. So let's copy from P2G source lib P2G. This is in source, I think. Make. Let's see if this looks different. So that's promising, but not particularly exciting. I'm expecting the same behavior, yeah. Look, that's good to fix. I mean, it didn't break anything, so that's phenomenal. Phenomenal. Lib P2G. Very, very good news. Let's see if I can find draw rect filled strips. This does F2I4, yes. So this does the fixed point conversion. Okay, so we don't need to fixed point convert stuff. I also like this magic number that gets subtracted, which is there for a reason, and that's, yeah, very, very, very doable. Okay. That's good. That's good to know. So I mean, it's good. It's good to fix things, right? We're good with constant, steady, incremental improvement. This is the name of the game. Wonderful. So here's another fun thought. What if I just don't draw the tile map, right? We expect to still see the thing because it's the upload that's causing the problem. If we do nothing else but upload, the box of doom is still there. The upload every frame. Well, no, but I started uploading every frame again. So yeah, if I go back to not uploading every frame, then I don't have that problem. Then I don't have the box. And don't say the solution is to not upload every frame. That's important. That's kind of important. It's not super important. I could do without it, but that was the whole point of my VRAM management strategy. So no box. Well, yeah, the problem's the upload. Exactly. And annoyingly, that's the thing that isn't as well logged in these files, right? It's a bit harder to find where the upload is. I'm uploading the whole texture into VRAM. So I guess I should re-enable trace logging. Actually, I think this is enabled. I just need to put it log level. Oops. Okay. So we've got stuff happening. We've got stuff. Actually, I need to let that run for a second longer, I think. I like that you can actually see the garbage for a second. And you can see it's very much not square. Okay, beautiful. That's more than enough data. So, upload texture. Okay, we put it at 0. That's not right. We should never be using VRAM address 0. That's not right. But then we seem to get the idea. So there's one dud upload. Then we put it somewhere else. Oh no, hold on. This is the fill. This is just the fill. This is just me filling all of VRAM. Okay. Well, that doesn't exist anymore, so that can go away. What's the Q parameter in the PS2 SDK stuff? The Q parameter is the perspective. I think. Hold on, let me... Q? Yeah, RGBA Q. So the perspective correction part of texturing is set alongside RGBA because there was enough room, I guess. It fit there. So you set your UV or ST, and then you send the Q with your RGBA, depending on the path you use. It actually, hold on, this is a bit of a sidetrack, but it's interesting to look at. RGBA Q. So this is the actual, wait, is this the register or is this the, this is the actual register, right? Yeah. So this is the register. So because RGBA are so small, the perspective correction fits here as well. The UV also had room for it, so I don't know why it's not here. Honestly, it's another PlayStation 2 thing that's kind of complicated. Oh, sorry, the actual... Sorry, this thing, yeah, it stands for, I guess, quad word, 128-bit. It's a buffer of quad words. But yeah, the Q++ stuff I found really annoying, which is why I wrote all my own code. I always assumed it was Q for quad, because yeah, it's 128-bit. Where is it? Because there's Q, and this is the Q I was talking about. But then there's the Q, which is the Q word T, which is defined as Q word T. Is this a union of things, but primarily this. It's fun. It's fun. Anyway. Let's look at this log a little bit more carefully. Let me double check that I'm doing the right thing. Am I uploading every frame? No. Okay, so let me go back to uploading every frame, because that's when interesting things happen. That makes sense. That makes sense why I didn't see what I wanted to see. Cool. Cool, so we're gonna upload a bunch of textures here, and we're gonna see the things increase, and that's good. And then we're gonna get to a certain point. We've filled up VRAM, I think. Now we're here. Okay, so we're doing 2 uploads, and that's okay. That's okay. Let's really hone in on the dud texture. Let's really hone in on the dud texture. Let's just not upload this other one. Nah, screw it. Let's keep it. And then let me just also work out, I log something, level entry VRAM head. This is what I want. Level entry VRAM head. So 1312160, whatever that is divided by 4. 1312160 divided by 4. 328040. Do we see 328040 in here somewhere? No, of course not. Oops. Of course we don't. At 329728. Yeah, sorry. I should change stuff to words. So this is in I'm pretty sure. Hold on. Draw 2D upload. I think VRAM address is in words here. Yeah, it is. Cause I need to make I don't know. I need to make it in words. Also, yeah, not being in hex is really dumb. I should do that pretty much everywhere. Just turn it into an X. Or a capital X even. So 329728 and swap. That's the wrong main. So the bigger number should be our entry level. Does that make sense? Maybe 329. So what we're saying is we're putting a texture from this address in EE memory. We're putting into this part of VRAM. We set some stuff up to do it. We are gonna upload 7 packets because the size in blocks. Size in blocks is how many. Size in blocks is how many. Yeah, block size bytes divided by 16. Okay, that's good. So that's a block size bytes. That's a constant. Block size. I don't know where I got this number from. What's 4496? I don't know. It's interesting. I divide it by 16 to get it in terms of in terms of a block size. Quad count divided by block size. This is I'm pretty sure it comes from PCSX2. From I keep saying the wrong thing. From PS2 SDK. Hold on. That's a different number. But that's because that's a disk. 7FFF? No. Okay, well I made up a number. Okay, that's probably a sign that something's bad. That's probably not good. Why am I dividing it by 16? Largest QWC. The point of this is packet count. Yeah, so then this is how much we're sending per packet. 16-bit. Largest QWC. Yeah, in DMA. So we've ended a CNT. That's fine. Yeah, so we've ended our last DMA tag. And now for everything. Oh. If our draw buffer has run out of size, we upload it. Otherwise, we start a new DMA tag. We start a new GIF tag. We start a new chain of GIF tags. Block size. So what should I hardcode block size to? So this is how much. Yeah, this is so. Yeah, why have I picked this weird number? Plus equals block size times 16. So yeah, let me try a bigger number. Block size is the size of the block size is the size of the thing we're copying to oh god, this is I wrote this ages ago. Block size is the size of the chunk of EE memory we're sending into VRAM. And for some reason I put an upper limit on this that I seem to have pulled out my ass. So this is so we have a DMA not a CNT, a ref. QWC. Could be. Let me try it. If I want bytes. Well, I don't want bytes, right? I want words. So let's try QWC. How many quad words? So I can just do this in one go. Let's try it. Make. I think PS2 SDK does something like that. I think it does it. I think it has an upper bound. How does it upload a texture from allocate? Maybe it doesn't. GIF block size. Yeah, okay. Okay. Let's see what happens. Let's see what happens. I still have trace logging on. Okay, well that looks promising already. If that, wow, maybe that was it. Maybe I was just doing something weird with blocks. Yeah. Okay. I feel like I had it bigger at one point, but I've also had so much VRAM fuckery that that's probably it was probably the wrong solution to a different problem, you know. My VRAM stuff doing this specifically I found like 2 or 3 subtle bugs in my VRAM handling that have, so I can get rid of this. Okay, I'm gonna peel this onion one at a time. First thing, get rid of trace logging. I really hope this works. That would be amazing. That's a really good spot. Yeah, and the point, it's a little better. It's a little better because the texture showed up and it didn't show up before, but we still got the mystery box. Still got the mystery box. So, wait, let me just make sure. Let me just make sure I'm looking at the right thing. That's the wrong thing. No, that's not the thing I meant to block out. Okay. Okay. So we're just drawing the one thing. We're not doing much VRAM fuckery. Okay. Okay. Good. Good. That's good news. That's good news. Do fewer things. I like this. Let's get rid of this padding, because that's silly. We shouldn't need it. Shouldn't need to exist. This moves the boxes back to where they were before, and that's good. That's okay with me. That's okay with me. It does look like occasionally we can see something flickering through this box, which is interesting. Very interesting. Okay. So we're gonna go back to trace logging. Oh, it's like something blank has been uploaded from the EE other frame buffer. Now that's interesting, because this is an ordering problem, right? Wait, hold on. I'm uploading every frame. I'm definitely uploading every frame. No, you're from the EE over. No, yeah. No, yeah, you're right. And it's an ordering problem because we upload the tile set, we draw it, it works, but then we've somehow also cleared a region of the frame buffer. That's what confuses me. When I wasn't drawing the tile buffer, the tile set at all, I was less confused. Now we draw a tile set, it's kind of like if I could see that tile set on the screen twice, like I could earlier, then beautiful. Like I know what's going on. If I dump the drawers, does the black box appear between RT1 and RT0? Black box. So if I look at all of these, so let's have the numbers up as well. There's a way I can do this. Hold on. There's like an overlay. Show. There we go. Okay, so now it's small and shitty, but we can see. Okay, so we're going back to the start. RT1 of one drawer, RT0 of the next drawer. What's RT0? Just 100% confirm it. I don't know what RT0 is. RT0, RT1. Oh, you mean like the register? Render target before draw. Okay, yeah. RT1's after draw. So let's find a frame where we can see stuff. So this is the garbled frame buffer, and that's good. Then we have the fact that I draw this nothing is weird. And then yeah, we have the black frame. Then we draw tiles. Then we see the other frame buffer in all its glory. And then it disappears. I don't understand why this happens in bits. I'm seeing a lot more of the... I'm a bit confused about why I saw so much. So where do I see RT0 and RT1? Like I'm not sure where those appear. Is that like in 18? Dump pictures. Yeah, it looks like that's what I've got, but I'm not sure. I don't. Oh, I do have some of the checkboxes not checked. Hold on. Let me. I've got trace locking on, so it's very, very slow. My CPU fan's going wild. Save RT. Sorry, you're absolutely right. Cool. Let me redo it. Let me redo it with a Cena log level. And one thing I wasn't sure about before, by the way, this overrides everything in the file, right? In this folder. So here it is. Nice. Dash D. Yeah, overwrite. That's good. I wasn't sure if I needed to delete stuff to not have weird state. Random target before the draw. RT1 is after draw. Draw and the black box appears. RT1, one draw. So RT0. Okay. RT0. RT1. Random target 0 is before the draw. RT1 is after the draw. Okay. And we can see some stuff's blocked out here. RT0. RT1. So this is like a screen clear. RT0, RT1. So this is drawing our tiles. Okay, so we're building it up. So here the box is not visible. We can see the whole thing. RT0. That's not what I expected. Got rid of the offset. Hold on. Okay, so so this is the culprit. We're doing something with this weird little chunk. I don't know what that size. What's that size? I don't know where this has come from, but this is 1047 RT0. So we're rendering to here, and it looks like we're probably, what the hell? Oh, that's weird. So 1047. Does that keep happening? Yeah, it does. I've got a weird... something's drawing where it should not be. 47. So, the only thing is, can I... It's like, this is where it's happening, right? But this doesn't really tell me much. It's a draw. It's a draw. Draw 10. So... context. So draw 10 context says that so it says the frame buffer is at where we think the frame buffer is. It's drawing primitive 6, which I'm guessing is a sprite because I think I'm only drawing sprites. Text A fog sprite. This was the last transfer we did, but maybe it isn't a transfer. Maybe it is a funky draw. 29EO. I would need to double check because my addresses are in bytes, which is very silly. They're all logged in useless byte formats. Drawing weird stuff. But that's the render target, right? The render target wasn't even full size. So, frame. It's like we changed the freaking width of the render target, right? Why was the render target small? So it was F47 RT. It was RT0, RT1. It doesn't really matter. Like, how big is this? 304 by 104? Draw 10. You are correct. 10. I don't know what F47 means. Draw 10. And the address of the frame buffer, which looks correct. Like, that's 8CO. Frame 47. Okay. So when I look at... But so... What does this... Like, this is draw 10. What frame does this correspond to? Not the frame that... I'm a bit confused by some of these files. Unless... I mean, the stuff I'm drawing, it should be the same. RT will ensure the area it's drawing to. Okay. Oh, so that makes perfect sense then. Because I guess that's where we're drawing... I guess that's where we're drawing... I guess that's where we're drawing our player entity, right? Maybe? So some of them are smaller, some of them are bigger. I'm still stressed by the fact that that's the wrong size. So where do we ever see the gap appear? And it looks like here we do. Here we can see the gap. Frame 46, draw 12, we have a gap. What's the vertex for that draw? For draw 10, vertex. Oh yeah, that's a much better idea. So yeah, it looks like a normal texture draw. Or the player draw? Vertex 1. So it's 10. It's 8 pixels wide. How wide's my player? 9 pixels wide. Oh yeah. Yeah, it's 9 pixels wide. My mistake. I can't do maths. So this is drawing the little player box. So maybe it makes sense that it's a smaller area. God. Yeah. Cool. Okay. That makes sense. I got thrown off by the fact that these were still set, but they are just set. That's how they go. So that's fine. That's fine. We're happy with that. So I guess the thing is, right? So if we follow a frame through or draw through, so it's like the render target before the frame, the render target after the frame, right? We've cleared the render target before the draw, the render target after the draw. We've cleared a frame. Before, after, we've done nothing. I don't know why we've done nothing here, but we've done nothing for some reason. Here, I don't know what's happened here, right? This is like a no-op draw. I'm a bit confused by that. So here, we actually clear this thing, finally, which is good. Here, we draw our tile set, which is good, and we see there's no gap. So our render target does have the tiles drawn correctly to it, which is what we expect. The thing has to come after, and this is 8CO. And then we look at the other render buffer again for some reason, the other draw buffer. Then we do a little draw here, we draw the player. Then the player against a background. See, so half a tile 2 is missing on the right. Here? That's just because of the cropping though, right? Or do you mean here? Oh, yeah, I see that. Whoa, good eyes. This is why I picked a very regular pattern. What? Oh, it is. You're right. So there is a broken box. So we're drawing the tiles. That makes less sense to me. I would have thought we would have drawn a full tile map and then there would have been a chunk taken out of it. How do we do a draw that it has a gap? How do we draw a gap? This raises more questions, Refraction. These aren't answers. Man. I'm drawing individual tiles, yeah. It issues a lot of draws. It's probably suboptimal. I should probably do some kind of meshing, but for now I just issue individual draws, you know. So it's in draw.c, sorry. Draw tile map. Something's going over it. Yeah. Put tile. It just does it. I mean, then you have to go into like my library code. So yeah, where do we draw the tiles? We draw the tiles to the, like, where is in what coordinates? Because we draw them in, like, this is all in game world space, and then when we call into my library code, this is where we do my conversion to coordinates. Wherever that happens, gift tag, st, rgb, aq, xyz, to coordinate. -3. Okay, hold on. There's more weird coordinate stuff happening here. Because... Which draw? Sorry. So this is draw 9. But is it always draw 9 in every frame? Or is it always draw 9 in every, like... Oh, this only increments. Hold on. Okay, I'm with you. So it's draw 9. I don't know. It's this F counter that increments in a strange way that confuses me sometimes. It's draw 9. So let's have a look at draw 9. Vertex chords. Okay, here we go. These are... F is the frame. Oh, okay, yeah, no, that, yeah. I would have thought we would have drawn something every frame. It feels like it goes up too much, you know? But maybe my code sucks and I miss frames. I don't know. This is a lot of vertexes. Okay, here we go. So this is our big frame draw. That might be the next problem to solve for fraction. There's always another problem. So this is like the big vertex queue that PCSX2 sees. That's great. I love it. What's the RT1 for this draw? Okay, so RT0, RT1. Okay, RT0, blank canvas. RT1, tiles have been drawn. And the box is already there, yeah. Let me just like visually double check, right? That's where it appears. It's hard because... So where's the... Oh, and the numbers change every time. That's also fun. But yeah, I guess that is about where it appears, right? So, am I scissoring wrong? Entirely possible. So it kind of lines up with the edge of the... Oh yeah, and this is going to change every time. But yeah, that's certainly where it lines up. It cuts the 9. Okay. The fact that when I stop... Well, here's how I know it's not the scissor. Okay? Because I can go into my code and I can say, don't upload this every frame, and it goes away. That's how I know it's not scissoring. Now it just draws nothing. But if I draw my other chunk of the level, again, it stops. The box disappears, right? Oh no, I'm drawing both chunks. If I load the other chunk of the level. What was the draw I was doing the offset on to move the blank box? The offset I hard-coded. Interesting terminology. You've never changed a scissor register before? The draw you were doing the offset on, what do you mean? What blank box? Do you mean the like the player box? The offset I hard-coded. Is that the... Yeah, for some reason I have this 320 pixel offset. I don't know what that's about. The black box from split between... I had a random offset. Split between two lines. Oh yeah, I put an off. I just after my frame buffers, I tried just bumping it down, right? Because here's the other thing. I probably can actually make it disappear. If we put it back out here, and I go into main, I probably can find a weird bumper that moves it. Let's say VRAM pad. VRAM. What's it called? VRAM pad. I can move it around a bit. Depending on what number I put here. Here it's split over two parts, but yeah, if I make the number bigger, it moves it down. VRAM pad just so in my it just puts space in my VRAM allocator that's just empty. So what I'm doing is moving the place in VRAM that the texture will get allocated to, basically, So I call pad after I've allocated, at this point in my program, I've allocated my frame buffers and my Z buffer. And then if I put this pad in here before I allocate my texture, it moves where the box is on the screen. But I've checked the address, and the address seems okay. And the upload address seems okay. So I'm confused. Like, I understand why this works. I understand exactly why this works. It's because it changes where we're uploading the texture to. But I don't understand why it's a blank box. And I don't understand why it's quite behaving like this. So if I change this to like 20,000, which is too big, am I clearing the areas I allocate for the texture? Am I clearing the areas I allocate for the texture? No. I'm never clearing them. I just jam data from the emotion engine into it. There's no concept of a clear and upload. It always does the dumbest thing. It would be hard, I would think, to clear a region of VRAM before uploading a texture to it. Or not hard, but you would need extra GIF tags. You would kind of know if you were doing that. It's just very confusing, right? Context for the tile drop. Context. Okay, so for context 9. Okay. Context 9. In a very small, hard to read size, but context 9. Alpha, scissor, alpha, and test. Alpha test not equal Z buffer only. That seems okay. I don't know if I want Z test enabled really because it's 2D. Maybe I should try disabling the Z test. That feels not invalid. Yeah, it couldn't hurt. It doesn't make sense really because it's not a draw, it's just copying, but let's give it a shot. Let's just see. Now. Don't know if I have an API for that. Don't turn it off. Oh, hold on, yeah. So what's Z? Oh, let me find my Z test, then TE. Oh yeah, okay. You're not allowed. Are you not allowed? Should be set to always. Z test. Where is it defined? Always. This is alpha test, Z test 1. And we have it set to equal. I think I have to change this at a library level. That please excuse this jank. Z test. I think it's all pass. We need to also all pass. Okay. This is very jank, but that's okay. Would've. I hate when you start pressing up to find something in your history and you get partway there. And then you realize it would have been easier to just type it out. Okay. Are you fucking joking? Are you fucking joking? What? Refraction's gonna come in. He's gonna explain everything. This is the answer. This is the payoff to like 4 hours of live streaming. Oh my god. So, I feel like Refraction's got it. I feel like he's cracked. He's cracked the puzzle. Uploading to 0 or previous draw has a high Z and it's screwing it. Yeah, one of those. You can spitball. Yeah. Wait. Greater equal. So it wasn't just greater, that's the other thing. And it's also weird that it's that little region that moves as I change where it's allocated. So uploading to your Z area feels the most likely here. That feels like the most likely candidate. Okay. So it looks like there's a region of the Z buffer. Dump my Z textures, yeah, okay. I'll do that. But I think I need to do that off camera. This has been a fun stream. This has been a fun journey. And we've finally worked out that the Z buffer is the problem. It's the source of all problems. So, actually, maybe I'm gonna just like, we're definitely dividing this by 4. Definitely dividing this by 4. It feels like Z buff adder. Does the Z buffer address have the same word thing? Frame. Z buffer settings, ZPM, word address, divide by 2048, same as frame. Okay, so yeah, shares the width. Shares the width, that's all good. That's fine, okay. That's worth looking at though. I wonder if the Z buffer is just pointing at the wrong spot. That could explain it. Anyway, that's been fun. That's delightful, isn't it? It's always the simplest things. So this has been a fun stream. It's good to get back into it. I'm going to be doing more and more streaming over the next few days. But I also might start looking for a full-time programming job again. So hopefully I can get some good stuff finished before then. Awesome. Thank you so much for hanging out, Refraction. You are an absolute legend as always. That's amazing. That's amazing. And thanks to everyone who's been hanging out. We've had a few people lurking. So hopefully it's been an enjoyable journey. Didn't consider it could have been a problem with Z. Always got to consider it's a problem with Z. Especially on the PlayStation 2 when Z can be funky. If I was doing a Z test grader, it would kind of make sense because everything has the same Z. So once you've drawn something at the fixed depth that everything in my 2D world lives at, then nothing else is going to draw over it. But that wasn't the case. This was actually most likely where we're putting the Z buffer. We can work this. We can fix this. We're going to throw some viewers onto someone in a raid. And I've got to find someone cool to raid. So we're going to hunt for someone cool in software and game development. I'm always happy to take suggestions for a raid. If anyone hanging out has someone to suggest, any of the lurkers hanging out, always happy to take a good suggestion. Always happy to look for someone doing something cool and interesting. Someone, using NeoVim or some kind of Vim. Someone doing something exciting, a little bit different. That's always what I'm kind of looking for. And probably not in Russian. There's a lot of Russians live right now. Nothing against the Russian language. I just like to understand the streamers that I watch. Co-learn with a penetration tester. That sounds kind of fun. Cybersecurity news. Unity. What's a Unity? Image like a friendly. What are they building? React. I have no beef with React. I just don't know if it makes the most exciting stream. JavaScript and Python. Open source project management system. JavaScript and Python. It's kind of cool. Edge cases. Let's have a look. Someone's doing some edge cases, I assume in Unity. Let's have a look. Let's look at some edge cases. Thank you so much everyone for tuning in. Oh yeah, also I put one of my new emotes in. It's not finalized yet necessarily. I've got more coming, but there are new emotes on the way. There's 4 others that are going to be some subscriber only, some welcome for everyone, and they're all really lovely, drawn by my wonderful friend Ryan. So, thank you so much for tuning in. Let's go share some love with Red Cabin Games, and thank you everyone. Thank you everyone who's been following on YouTube, and I will catch you all very, very soon. Bye.